Saxon's Calculus Lesson 84 is about integration of odd powers of sine x and cosine x. So in the first example, they ask us to integrate sine cubed x dx. Now, in order to do that, I need to split it to an odd number, typically sine x, factored out to split it into two pieces. So I'm going to change this to sine x multiplying with sine squared x. And then the sine squared, I need to substitute it in for its other format, which was 1 minus cosine squared from that original equation formula that we learned. So 1 minus cosine squared x. And all of that is still actually, let me distribute and then I'll do that. So sine x times 1 is sine x, and then minus sine x cosine squared x. So this is what we are trying to integrate. So we're going to deal with them separately. So what is the integration of sine of x? Well, it came from negative cosine of x. Then we have the minus, and now this is a multiplying part. So I have to deal with it as in the squared part, I assume, is my u. So if I derived, because again, I'm working backwards. If this, let's integrate this part as if it said u squared, which would give us 1/3 u cubed. And since my u is cosine, I'm going to write that as cosine cubed x. And then if I were checking my deriving, would that give me the sign that's with it? Yes. So far, this one was negative cosine. This one works and checks out to be the negative 1/3 sine. Sorry. 1/3 cosine cubed x. Yes, for a split second, I had a, yeah, and then our plus c, and we're good. Okay, example 2 wants the same thing, except it wants the integration of cosine cubed. Now, do I need to write this one out? It's going to work the same way where you're splitting it to cosine and then cosine squared. The cosine squared is going to change over to the 1 minus sine squared. You're going to distribute out, and then when you integrate, the cosine that you separated out goes to sine of x. Ooh, I wonder if my pen is dying. And the minus, and the, oh, it is, and the 1/3, as this one was 1/3 sine cubed x plus the c. Okay, so I got a different pen, and I've now written that answer in and actually boxed it so you could see it. Example 3 is this. And so now we are going to treat this cosine cubed just like we did before, where we were getting this answer, but we still have this sine to the 4th to deal with. Now, since this one is even, I don't need to be splitting it up. So I'm going to treat that as in u to the 4th. So we're going to make that one 1/5. Our u goes back to being sine to the 5th x. And then we had, and I said I was referencing this answer, but I have to remember that this sine to the 4th was affecting this. And so what you need to picture is, and again, I didn't write out all the steps on that one because I was using this one as reference. But if you picture this sine to the fourth multiplying in with, oh, and I hate that I didn't write that out. Maybe I should pause and write that out. Okay, so the sine to the fourth x was with, and then we split the cubed into cosine and cosine squared, which we substituted as the 1 minus sine squared. So when I distribute with the 1, I get this piece, which is where this is coming from. But this one became sine to the 6th x. Oh, it was minus. And that cosine is still with it. All right, so where does this come from? Well, if I integrate that one, we get the minus 1/7 sine to the 7th x plus c. Now, example 4. Integrate sine cubed x cosine to the 7th x dx. So the sine cubed is going to go to sine x, and sine squared, which is going to go to 1 minus cosine squared x. And the cosine to the 7th is going to stay. Then, so once I'm here, we're putting our cosine 7 and our sine with the 1. So I'm treating it just as I am this first part here. So then this becomes 1/8 with our cosine to the 8th x. But I have an extra problem here, because when I do cosine and I'm working it backwards, I get negative sign, and I don't have negative sign here. I have to negate that part. Then when I put the cosine squared one with the cosine 7, I get cosine 9. And because it's minusing, but I'm also changing the sign, it's going to go to a plus. And since it was 9, we're going to add. So 1/10 cosine to the 10th x plus c. Minus, positive, yes. Okay. Example 5. Integrate sine squared x cosine to the 5th x dx. So I need to split it up and keep our sine squared x, cosine x, and that leaves a cosine to the 4th x. And I know I want to substitute the 1 minus sine squared here, but it's not cosine squared, it's cosine to the 4th. So technically what I'm doing here is I am squaring that. It takes 2 sets of those to make to the 4th power. So I'm going to cross this off so that I don't get confused as I'm looking through here. So when I multiply with the 1, I have our sine squared and our cosine. The cosine comes from the sine, so I know I'm good there. So we're going to do 1/3 sine cubed x minus, and then our sine squared went with sine squared squared. So that should be a total of 6. Yes. Then that's going to be 1/7 sine to the 7th x, and the cosine is already there. And I know I want my plus c, but I think I've missed a piece. Yes, because this is squared, I have dealt with the first and the outer pieces, but implied in my squared is the middle term, which would have been 1 times sine squared is sine squared negative, but we're doubling that to -2 sine squared x. So I need to do the same with this one and this one. So I have a total of 4 of them. So we're going to make it 5, but the 2 is there. So minus the 2/5 sine to the 5th x plus my c at the end. Let me just double check that. The 1/3 with the sine, this one should have been in the middle, minus 2/5 sine to the 5th, and the 1/7 and our plus c. Yes.